This is question 7B from summer 2021 paper 4.1. Now, there's a mixture of serine and lysine reacting together to form several different products. So part 1, they would like us to draw the structures of the two structural isomers with the molecular formula C6H12N2O5 that could be present in the product mixture. Now you have serine and lysine in the mixture. That doesn't mean that your products must be a product of reaction between serine and lysine. Now, these two are amino acids and they have at least two functional groups, NH2COH, and they can have other functional groups in the side chain, right? So serine can react with serine, lysine can also react with lysine, okay, instead of reacting with each other. Now, I want to write down the molecular formula for both serine and lysine because they give us the molecular formula of this product that they wanted us to write the structures. So let's just write down, very simple, just count the total number of carbon, 1, 2, 3 for serine, total number of hydrogen, 1, 2, 3, 4, 5, 6, 7. Then nitrogen, 1 only, and oxygen, 3. Now let's look at lysine. Lysine has a bigger molecule, so 6 carbon, 4 here, right? 1 more here, another 1 here. H, 1, 2, 4 times 2, 8, so 10, 11, 12, 13, 14. N would be 1 and 2. So in lysine, there are 2 amine functional groups, and finally, the number of oxygen, 2. Okay, now serine 3 carbon, lysine 6 carbon, and they wanted us to draw the structure of isomers with the molecular formula of this, right? So if you look at the molecular formula, 6 carbon, lysine also 6 carbon. So it cannot be lysine alone not reacting with anything. Okay, they won't ask you to do such thing. And if you look carefully, the number of hydrogen, nitrogen, oxygens are different. Okay. Serine has 3 carbon. So it's very high chance that it is actually a product of 2 serine reacting with each other. So let's see, if I have 2 serine together, C 3 times 2, H 7 times 2, right? And 2 O 3 times 2. So I will get, this is 2 serine, okay? C6 H14 and 2 O6. So what's the difference between these two? Would be minus H2O. See, 2 hydrogen less and 1 oxygen less. Then these 2 serine, okay, right, minus H2O, we get the product C6H12N2O5, sorry, right? Okay. So this product is actually a product of condensation of 2 serine molecules. Now, let's look at serine. It has 3 different functional groups. The common one in all amino acid, amine and carboxylic acid, but there's another one, alcohol here. So let's see, this NH2 can react with carboxylic acid. Condensation reaction. Okay, you get a bigger molecule and minus remove water. COOH, the carboxylic acid, can also react with alcohol. Okay, also remove 1 water and we get a bigger molecule. Now this product will be an amide and this will be an ester. So this will be the structures of the two isomers that we need to draw. Right, now let me draw the structure of serine. COOH on the right hand side, amine on the left hand side, and then the side group, which is CH2OH. Okay, let me erase. I've left out the CH2. Okay. Now I'm showing the process, okay, of the reaction, but in the exam you only need to draw the structure of the products. Yep. Okay. Now in this case, I want to draw the first product, which is the amide. So these two functional groups will react with each other. They remove water. So now the C double bond O and NH will join together. So you should see the amide link. Now I'm drawing it this way, okay, because they say the functional group form in each case should be displayed. You can have a structural formula on both sides, but okay, the functional group should be displayed. Right, the rest of the parts we just copy because they don't undergo any reaction. Okay, so this is my first isomer for C6H12N2O5. Now, I want to draw, okay, the other product, the ester. So in this case, the COOH will now react with the OH from the side group, right? So let me rewrite the structure of serine. This time, I want the COOH functional group, okay, to face the OH functional group of serine. Okay, now the carbon in the middle is still the same. Now I'm just changing the position, right? Just rotate the molecule so that now we can see that these two are reacting with each other, and the product will be CH2OH, NH2 no change, COO. Okay, I'm displaying the functional group. Okay, so right now I have the structures of the two structural isomers with the molecular formula of C6H12N2O5. Because water is the side product. Now again in the exam, you need to show the structures of the final product. Okay, now let's go to part B2. Right, now part B2, they would like you to predict the number of different structural isomers with the molecular formula C9H19N3O4. So this time, okay, they want you to predict the number. Okay, how many isomers can be formed from a mixture of serine and lysine with this 9 carbon product. Okay. Let me go back to the previous one. Okay, I want to copy down the molecular formula of serine and also lysine. C3H7. Okay, N1 and O3. This is C6, right? H14, N2, and O2. Okay, so this time you could have already guessed that this will be a product from the reaction between one serine and one lysine. Okay, so if I add these two together, okay, I'll get a total of C9H21, okay, N3O5. So again, we compare these two and we realize that from this, okay, let me cancel this arrow, from here to here is actually minus water. So again, they undergo condensation reaction. And if you do not have time to just, draw out all the structures of the isomers, okay, you can use the clue from the previous question to predict how many isomers, right? How many functional groups are there in serine? 3. In lysine, 1, 2, 3. Also 3, right? So let's check and see which one of them can react with each other and give us and undergo condensation reaction. OH with COH, yes. Okay, condensation. So we will get one product. Then the NH2 from serine and COOH from lysine, another condensation reaction. So everything I write on the left-hand side, okay, they are the functional groups from serine. Okay, what I wrote on the right-hand side will be functional group from lysine. So what other functional group from serine which can react with functional group from lysine, okay, in a condensation reaction would be, okay, COOH, this time COH from serine, and NH2 from lysine. So this will be the third, okay, the product will be the third isomer with this molecular formula. Let's check anything else. COOH NH2. Oh yes, because this has 2 NH2. Okay, so this will be NH2 number 1. Okay, let me put this at NH2 number 1. This is NH2 number 2. Okay, COH again, but this time with the second amine functional group. So that will give us the fourth isomer. Now let's look again whether there will be any other combination out of these 4 to form a condensation product. I see none. So I'll predict that, okay, the number of structural isomers formed will be 4. Now, of course, okay, if you think that, okay, you cannot predict the number like this, then what can you do is you have to go through a more tedious method to solve this question, which is to draw all the structures with this molecular formula. Okay, and still you have to know these 4 reactions. Okay, now let's go to the next one. This time I'll just draw all 4 of them to show you. So the first one I want to show is the common one, because we are talking about amino acids. So let's draw the structure of amides formed from these 2 amino acids. Okay, I'll draw serine on the left and lysine on the right-hand side all the time. I'm just following this order, okay, in the question. So this reacts with the first amine functional group. Yep, this is the second one. the first amine functional group, okay, which is CH2, 4, right? And I have the H and H2 and COOH, right? So I'll get an amide CO and H, right? If you cannot remember the reason why I display the functional group of amide like this, okay, then you can go and look at the previous video on the organic nitrogen compound chapter. Okay. Now, of course, if you want another video to talk about that one, then just let me know, comment under this video. So first product, all right? Now I use another color for second product. Right, second one, still an amide, but this time what I want to do is I'll make the COOH of serine to react with the other NH2. Okay, the other NH2, NH number 2. Okay, so I draw this here. This time is still H. This one I'll change it to this position. CH2, 4 NH2 and COOH. Now again, I'll get an amide because these two functional groups will react with each other. Okay, for serine, it's quite simple. It's a 3 carbon molecule only. Lysine is a big one. Okay, now second product. Right, let's draw the fourth one. Right, the fourth one, again, another color. Guess I have to draw it smaller so that I have enough space to squeeze everything in, okay, on the same slide. Okay, now this time, still an amide, but okay, it will be the NH2 of serine reacting with COOH of lysine. So I'll still draw serine on the left-hand side, but of course now I'll be flipping this molecule so that NH2 is now on the right-hand side, facing the COOH functional group of lysine. H2, let's see, CH2, 4, and H2. Okay, now I'll get another amide. Now, of course, again, you do not have to show all these equations, right? Because they only want the number. So this will be your rough working, which you can write on a blank page. Normally, it will be provided, some of them will be provided in between the questions, usually for a longer question, because they knew that you will need more space for rough working for a longer question. Right, so you can see that red color, one product, blue, another one, green is the third one, then now there's the fourth one, which is the ester, right? Which is this, the ester. Functional group OH from serine reacting with COOH from lysine, right? We go back, choose another color. Okay, purple. Purple is nice. Oh, okay, hold on, right. Okay, I'll just write it here. CH2OH of serine right, with COOH from lysine. So I will get Esther. Okay, let me draw the display the functional group first, yeah, so that you can see the functional group clearly. And I have C. Oh, so sorry, it's the other way around. Let me just erase this. The CO is supposed to be from lysine. Right, CO from lysine and O from serine. C, H, CH2, 4CH2. It's a very long side chain. Okay, O here, COOH, and NH2. Okay, so altogether, 4 isomers. So you can see very clearly that this method is very long. Okay, it's taking a lot of time for a 1-mark question. So, okay, if you can, you practice with more questions and get used to them giving you clue in the first part, and that part will, the clue from the first part will be continued to be used in the second one. That will shorten your time for the thinking process. Okay, so that's all for the question 7B. If you have any question, just let me know by commenting under the video. Thank you.